Hello team and welcome back to the channel. So as you know, when you are going for DevOps interviews, one of the most common questions that they ask, what kind of issues you have faced with Kubernetes. Basically, what kind of errors you have faced, how you have resolved it, right? So in today's session, we are going to discuss about the most important Kubernetes errors, the reason behind its occurrence, how we can debug it, and how we can resolve it. And also I'm going to explain each error with real-time examples, multiple examples, so that you gain a real-time knowledge about each of these errors. So if you are going to interview, this will be really useful. So make sure to watch this video till end so that you can check out all the errors, all the kind of errors and the solution to them. Also team, if you haven't subscribed to the channel, make sure to subscribe in order to not miss any of the videos. Okay. Now, as you know, I have launched batch 6 of DevSecOps and Cloud DevOps, which is going to get started on 30th of July. And this is going to be a full stack DevOps bootcamp course from scratch to expert. Also team, the best part about this course is going to be my dedicated support. So basically what I'm going to do help you with, firstly, everything I'm going to teach from scratch to advanced. Plus, I'm going to connect to you one-to-one, help you build your resume, explain you what kind of projects can be added and how to explain those projects. In addition to that, I'm also going to explain like what kind of task to be added in your resume and how to explain those. Plus, my own day-to-day activities will help you understand what kind of tasks happen in DevOps. Okay. So all the details about this course will be in the description. So make sure to check that out. Now, with that being said, let's get started. So team, let's get started. And now, first of all, we are going to get started with the most common error, which is known as CrashloopBackOff Error. I'm sure you might have already heard about it, but let us understand it in detail what exactly it means. Okay. So first of all, CrashloopBackOff Error means that when you are trying to create the application pod, it's not getting created successfully. Okay. Like basically when you are trying to deploy an application, it's pod getting created and then immediately it crashes, right? Pod is getting crashes immediately within few seconds as soon as you try to deploy it, right? So pod is not able to get created properly or successfully. Okay. Now, one thing you notice, there is a keyword here, BackOff. What exactly does it mean? Okay. So basically, when we run this command, for example, like kubectl, let's say I'm trying to deploy any application, -f, then let's say a.yaml, some application I'm trying to deploy by running this command. So what is happening there? Immediately when a pod gets created, it is crashing. Okay, it's crashing. That means that this pod is not able to run properly or not able to run successfully, right? So by default, Kubernetes, it has a restart policy. Okay, restart policy. That means if a pod is getting crashed, Kubernetes is going to restart it in order to fix it, right? Kubernetes might think, okay, a restart might be required to fix the issue. So it's going to restart as per the restart policy, right? But the problem that you might be facing in that case, let's say pod is not able to get up and it's continuously crashing. So if Kubernetes is trying to restart it again and again multiple times, then what is going to happen? Overload is going to happen. Like so much of request of like a huge amount of request for restarting a pod is coming, right? Which is going to cause issue to Kubernetes itself, right? So in that case, what happens? Kubernetes is designed to do something which is known as BackOff. Now BackOff basically means कि if a pod crashed, Kubernetes will try to restart it first time, right? Let's say when Kubernetes tried to restart it, it failed, right? So when it failed, Kubernetes, the time period between restarting the pod, it's going to increase exponentially, right? For example, let's say this is my pod I am trying to create. Okay, it crashed. It crashed, and as per the Kubernetes restart policy, Kubernetes is going to restart it, right? But again it crashed. So next time, let's say after exactly 1 second, Kubernetes tries to restart it, right? But again it failed. Now exponentially it's going to grow. Now next time Kubernetes will try to restart it after 2 seconds. Okay, let's say again it failed, right? The pod failed again. So next time, let's say after 4 seconds, it's going to try to restart it. Okay, because if Kubernetes tries to restart a pod every 1 second, too much of overload is going to come, right? So in that way, you can see exponentially things like time period is going to grow exponentially, right, between each restart. This exponentially is growing, like growing of time is known as BackOff. Kubernetes basically is going to wait a longer time before a new before trying to restart the pod again. Okay, that is known as BackOff. Okay, now let us understand why does this error occur, crash loop backoff error. What could be the reason? Okay, so there could not be any fixed reason because of which like there is no fixed reason or fixed reason for which we can say ki for this reason a crash loop backoff error will always occur. Okay, that means ki if you are trying to deploy a pod and if you are seeing this error, that crash loop backoff error, first thing that you are supposed to do is check the logs. Okay, so for that you can run the command kubectl, then logs, then the pod name, that is crashing. Okay, so based on these logs you'll be able to find what exactly is the issue. Okay, so now let us understand with some real-time examples what could be happening. Okay, 3 examples I'm going to explain. First example, basically let's say this is a YAML pod file. Okay, sorry, YAML file for a pod. Okay, inside one environment I'm adding, which is database connection string. Okay, so basically what I'm supposed to do, I'm supposed to provide the connection string so that this application can connect to a database. Okay, but let's say this value is not correct. Okay, so if value is not correct, then our application, our pod is going to crash. Okay, now how do we check it? So first thing that we are supposed to do is run the command kubectl logs pod name to check the logs of the pod. And based on if this value is wrong, what kind of error we are going to get? In output, we are going to get error database connection failed. Okay, because the connection string is not correct, then obviously connection cannot happen to database. Okay, so in that case, when we see the error, okay, database connection failed, immediately we need to check the where we have provided the connection URL. Okay, which is here. So this is one of the scenario, one example where you can get crash loop backoff error. Okay, after that, second example, let us understand. Second example that could be coming is because of like memory, out of memory killed. So basically this is another YAML of a pod file. So let's say I have assigned 128 MB of memory to my pod. Okay, but the problem is that pod is going to need more than 128 MB of memory. In that case, it's going to crash. Okay, if it is like, let's say by default my pod requires like let's say 1 GB or 2 GB memory minimum. In that case, if only 128 like MB of memory is given, immediately pod will crash. Okay, in that case again we are going to get the crash loop backoff error. Okay, talking about third scenario, what could happen in third scenario? So third scenario could be happening because of application error. Okay, so basically, when you are having a Kubernetes pod and you are trying to run an application inside a Kubernetes pod, but application itself is having error. Okay, if application itself is having error, because of that also we are going to get crash loop backoff error. Okay, so what you understand from crash loop backoff error, first of all, it could occur because of many different reasons. We can know the exact reason for which it is occurring is by checking the logs. That means first command that we are supposed to run, kubectl logs, then pod name. Okay, this is the first command that we can run. Second command, if you want, you can run. Let's say you are not able to get any information here, so you can run the second command, which is kubectl describe pod, then pod name. What second command is going to do? Basically this command is going to show you the events during the process of creation of the pod. What events happen, like Docker image got pulled, then container got created, those kind of events you'll be able to see. So it is possible that you might be able to see some error is happening here or so. Okay, so with help of these two commands you'll be able to find out the exact issue for which crash loop backoff error is happening. Okay, so okay, now let's move on to the next error. Team, let us discuss about the next error, which is one of the other very common error you might have already heard about, which is known as image pull back off, right? Similar to this, we have another error which is known as error image pull. Now let us understand the difference between them and the base of it, like why does this error is going to come. First of all, you can understand this image pull, and here also image pull. Okay, what image we are talking about? So as you know, in our Kubernetes YAML manifest files, we define the name of a Docker image which is going to be used for creating container through pod, right? So that Docker image needs to be pulled first in order to create the container, right? So this Docker image could be stored on some private repository or public repository depending on the requirement. Okay, generally private only. Okay, so let's say I ran the command. I ran the command kubectl apply -f, then let's say a.yaml file name in order to create the pod, right? But Kubernetes is not able to pull the Docker image, right? So if initial failure happens, initial failure means this is just happened first time, then what we are going to call it as error image pull. Okay, if it is happening first time. Okay, let's say second time also happen, then also we are going to call error image pull. Okay, so basically what is going to happen, let's say ki first time Kubernetes is first time, sorry about that, so let's say first time Kubernetes tried to pull the Docker image, it gave error. So Kubernetes is going to try again, right? Try again, let's say it tried after 1 sec. Again it gave error. So this time Kubernetes is going to try after 2 sec. If again it gave error, Kubernetes is going to try after 4 sec. This time is going to be increasing, and this increasing of time between this delay that is increasing between each retrial is known as BackOff, as I explained previously. Okay, that means if multiple times this error image pull is happening, then Kubernetes is going to start BackOff, and this is going to be this multiple occurrence of this error image pull. It's going to be called as image pullback of error. Okay, okay. Now let us understand why does this occur. Okay, why Kubernetes might not be able to pull the Docker image. So there could be many reasons. For example, let's say the image that you are trying to pull, it does not exist. Okay, this could be error, right? The image that you are trying to pull, it is possible that you might have written the wrong name of image, right? Some spelling mistake or so, or maybe tag is wrong for the Docker image, right? Third thing that might be possible, that is one of the most common cases, it's going to be that the image that you are trying to pull, it exists inside a private Docker registry. Okay, so as you know, if you are if you are keeping your Docker image inside a private Docker registry, and later on if you want to use it, you need to provide credentials, right? That means if inside Kubernetes you want to pull a Docker image that is stored on a private Docker registry, you need to provide credentials. How do we provide credentials in Kubernetes? We create secrets. It's an object inside Kubernetes which is basically used to store credentials. Okay, so we are going to create secret which is going to have the credentials of private Docker registry, and in our YAML file we are going to provide information like image pull secret, and then here we are going to provide the name, secret name, whatever we have created. Okay, so these three could be the most common error, the most common reasons because of which we might be getting image pullback of error or unable to pull the Docker image. Okay, it is possible that image might not exist. It is possible that the image name we might have written wrong, or the tag is wrong, or else credential could be issue, like it is stored on a private registry and we have not provided the credential. Okay, now the question is, how do we resolve it? Okay, so previously in CrashloopBackOff Error I explained that you can run the command kubectl logs then pod name, but wait, here you cannot run this command because pod is not at all getting created. In previous case it was getting created and crashing, but here it is not able to get created. So how do we debug this scenario? So here what we need to do, we need to run the command kubectl describe pod, then pod name. What it's going to do, it's going to give us events. What kind of events I'm talking about? So when this whatever steps are involved in creation of this pod, like first what is going to happen, it's going to pull the Docker image, create a container out of it, right? So all those events we can see using this command. For example, let me show you one example. So when you run this command kubectl describe pod name, these kind of events you might be able to see. Okay, for example, here you can see pulling image so and so, then you might see error failed to pull image. Okay, and error also you might be written pull access denied for non-existing image, like that. Okay, so based on this we will be able to understand what exactly is the error. Okay, so the way to debug it, sorry about that. So when you try to you can try to debug this error using this, and when you see when you describe the pod, then you'll be able to understand what exactly is the issue. Okay, so now let's move on to the next one. So team, now let us discuss about the next one error. So next error, I'm not sure if you might have heard about it, but it is also kind of like very common. Okay, node not ready. Okay, so basically when you set up Kubernetes cluster, in order to check if all the worker node they are connected with master node or not, what command we run? We run kubectl get nodes, right? In that case we get the status like of master node as well as worker node, whichever is ready or not. Okay, for example, the example output of running this command, you might be seeing something like this. Okay, where you can see there are two worker node and in below status you can see if they are ready or not. Okay, sorry, first one is master node, you can see here rules. So first one is master node which is ready, but second one which is worker node, it says not ready. That means if a worker node is not ready, that means we cannot deploy or create pods on that, right? So if we cannot create worker application pods on a worker node, there is no point of having that worker node, right? So how do we make it ready, or like how do we find it, what is the issue because of which this worker node is not getting ready? Okay, so there could be many reasons. For example, one of the reasons that could be there is that let's say this is my worker node. Okay, this is my worker node and this is my master node. So let's say it is possible that worker node is not able to connect to master node. That could be reason one, right? Second reason that could be there is that the worker node is what? Node is like a virtual machine only, right? It is possible that there is no resources available on the worker node. Resources means, let's say there is no storage left on the worker node. That also could be possible, because of which worker node is not getting up, right? Also, as you know, we have a component kubelet, right, which is responsible for creating the pods on a machine, right? So we need to make sure that on each worker node kubelet is installed. So this is also possible that kubelet is either not running, okay, or maybe it is having some error. Okay, so these three are the most common issues because of which a node like shows the status that not ready. Now how do we debug these kind of things? Okay, so first thing, like in order to check if the worker node is able to connect to master node or not, or basically ping to master node or not, we can run a command like this from worker node ping, then Kubernetes API server URL. Okay, so from here we will be able to see if from worker node we are able to connect to master node or not. Okay, second thing that you are seeing, there could be, it is possible that there is no storage left on the worker node. In that case, what we can do, we can run the command df-h, or you can even run df-kh. So these two commands is going to show you the detailed information about the storage, what is available, what is and what is being utilized. Okay, so from here we can understand if enough storage is available, we can understand, okay, this is not the issue. Okay, now third one is kubelet. If kubelet is running or not on the worker node. So for that also we have command which we can run. First command we can run sudo systemctl status kubelet to check the status if kubelet is running or not. Second command we can run sudo kernel ctl -u kubelet -f. So this command is basically going to give you the kubelet logs. So based on that logs also we can find out if kubelet is running properly or not. Okay. So for node not ready, this could be the issues and we can debug them in this ways. Okay. Now let's move on to the next one. So team, now let us discuss about the next error, which is pending pods. Okay. Now what exactly does it mean? So basically, let's say I want to deploy an application. So for that I run the command kubectl apply -f then YAML file name. Okay. But it was not able to create any pod. That means pod is in pending status and not getting created, right? So what could be the reasons? There could be so many different reasons. We are going to explore a few of them. Okay. So basically, you know, what is the process when you want to create a pod? How is the process goes? So first of all, the request goes to API server, right? After that, that information get updated in etcd. From there, scheduler gets to know that okay, there is a request coming for creating a pod. So scheduler is going to schedule the creation of a pod on a node, right? On a worker node. And after that, kubelet is going to create the pod, right? But here, if the pod is not getting created, what could be the reason? Okay. So there could be many reasons, out of which, let's say in my YAML file, I have defined that my pod requires minimum 2 GB of RAM, right? If it requires 2 GB of RAM and let's say we are having 3 worker node, okay? And as of now, on a not single worker node, we have 2 GB memory available. In that case, if no worker node is having 2 GB RAM available, then this pod cannot be getting created. For example, let me try to show you. So for example, let's say this is my application pod. Okay. So this is the configuration YAML file for the pod where we have defined that memory should be 2 GB and CPU is 2. Okay. But out of 3 worker node, not a single worker node having minimum 2 GB of RAM left. In that case, what is going to happen? The pod is not going to get scheduled. So in that case, what we are supposed to do? So in that case, first thing you can run, firstly, you cannot check the logs because pod is not at all getting created, right? So what you can do, you can run the command kubectl describe pod, then pod name. So once you run this command, you'll be able to see the events that is happening, or that will also give you the information about why the pod is not getting created. Okay. The output will look something like this, where inside events you'll be able to see type warning reason failed scheduling. Okay. That means the pod is not getting scheduled on a pod. Okay. Now what is the message you can see? Let's say there are 3 worker nodes. So out of 3 worker node, there is not a single worker node available. Why? Because 1 worker node is having insufficient memory and 2 worker node is having insufficient memory and 1 is having insufficient CPU. Okay. So this could be one of the main reasons because of which a pod goes into pending state and it does not, like, the pod is not getting created. Okay. Second reason that could be there is because of node selector. So we can set up a condition that this pod requires disk type SSD. That means it is going to search for a pod of a worker node, like, which is having SSD, right? So again, we are going to run the command kubectl then describe pod name. So there, inside that, in the event section, we will be able to see an error something like this, that's 0/3. That means none of the nodes are available because 3 node did not match node selector. Okay, that condition is not getting matched. Okay, so this could be second reason, or this is the second example. Okay, let's talk about third example. Okay, so third example could be because of taints and tolerations. Now you might be thinking, what is this? Okay, so basically taints can be applied to nodes. Okay, these are applied to nodes in order to repel or avoid creating a certain set of pods. Okay, and toleration is created on the YAML file of a pod. Okay, for example, let's say on pod I have mentioned that key is, let's say XYZ or something. I have mentioned this is toleration. Okay, and on all the worker node I have written as taints that the pod who is having key XYZ is not going to schedule, no schedule. So in that way, what is going to happen, that pod who is having this key value information, it's not going to schedule on any of the node whichever is having taints. Basically we are setting up a condition. Okay, so these three could be the main reasons because of which your pod goes into pending state and not at all getting created. Okay, now let's check out the other error. So team, now let us understand about the next error, which is known as forbidden. Okay, now in order to understand this forbidden error, we need to understand first the concept of RBAC. Okay, RBAC is what? RBAC is short for role based access control. Okay, now let us understand what exactly it is. Okay, so let us say we have a Kubernetes cluster, we want to perform deployment on it. Okay, so by default, we don't want that all the users who are able to access Kubernetes should be having permission to perform the deployment. That means we want that only certain level of people or a certain number of people should be having permission to do the deployment and some other person should not be having, right? So for that, first of all, what we do, we create rules. Okay, for example, let's say I created rule 1. In this rule 1, we have defined permissions, that is just read only. Okay, that means ki whichever user is having this permission, rule permission, that user will be having permission only to see the things, not modify, not change anything. Okay, let's say second permission I created, which is going to be let's say ki modify things. Okay, modify deployments, create deployment applications and all those things. Okay, third permission, the third rule that I created, it's basically, let's call it as cluster rule. Okay, a cluster admin role. Okay, now let's say we have like so many users, hundreds of users. Okay, out of which let's consider 3 users. Okay, user 1, user 2 and user 3. Okay, now my requirement is that key only user 1 should be having permission to perform the deployment. Okay, perform deployment or like modify any kind of things in our deployment. Okay, so what I'm going to do, I'm going to assign role 2 to user 1. Okay, I'm going to bind, that means binding, role binding is basically this one, user 1 plus role 2. Okay, so basically what here I'm doing, I'm binding a role to a user. Okay, now user 1 will be having permission to perform any kind of deployment. Okay, let's say for user 3, I want that user 3 should be having only permission to read things. Okay, not modify any kind of things, not perform any kind of deployment. So for that, I'm going to bind role 1 to user 3. In that way, user 3 will be having just read only access. Okay, for user 2, I want that user 2 should be having complete control or complete permissions over the whole cluster. Okay, so I'm going to assign user 2 to role 3, which is cluster admin role. Okay, so basically what we did, we created users first, then we created roles, and then we binded the roles to users as per our own requirement. Okay, so this whole process is known as RBAC, role based access control. The access is given based on different rules that we can create. Okay, now let us talk about the error that we can get. So let's say I'm trying to perform a deployment. I ran the command kubectl apply -f then a.yaml. Okay, I tried to perform the deployment by running this command, but I got an error. What error I got? I got the error that I'm forbidden to make these kind of changes. Okay, the error that we might be getting will look something like this: error from server forbidden, services is forbidden, user this is going to be the user whoever is performing the deployment, basically service account you can call it. Okay, cannot list resources. Okay, so why this will happen if the specific user, let's say I'm using let's say user 1. Okay, so if user 1 is not having complete permission to perform the deployment, then it's going to give the error forbidden. In that case, what we need to do? So first thing that we need to do is find what permissions does this user is having, right? So for that, what we need to do, first of all, one thing that we can check is like what permissions we are having. For example, I can run the command kubectl auth can I basically means I want to test like what if I have this permission or not. So what permission in verb and resource. So here what I can write list pods. That means I want to check if I have the permission to list pods or not. Let's say I want to check if I have permission to create deployment. So I will write here I will write create pods or create deployment. Okay, and for which I'm checking for this user or this service account. Okay, so in that way, first of all, we can check if I have this specific permission or not, right? But let's say I want to check what kind of rules is assigned to me and what permissions does that rule have. So next up, what we need to do, we need to first of all get all the rules. Okay, so once we get all the rules, we will first have a list of rules which are existing. Then we can describe those rules to find out what permissions those rules are having. Okay, after that, what I'm going to using, if you run this command describe rule, then you'll be able to see like what permission they are having. Okay, now after that, what I want to see that which user is having which role. So for that, you need to run the command kubectl get role bindings. Role bindings is basically an object which is created when you want to bind a role to a user. Okay, so when I ran this command kubectl get role binding all namespaces, then all the role bindings like which user is binded to which roles, we are going to get all those information. Okay, now, and once we run this for each role binding, if I run this command, let's say describe role binding and the name of the role binding. So in the output of this command, you'll be able to see that which service accounts are added or which service account are added in this role binding. Okay, so from there we will get to know like if we are having like performing all these commands. Through that, we'll be able to know if we are having enough permission to perform the deployment or not. If not, then we need to add those permissions in the roles. Okay, so this is how we can fix it. So team, let us discuss about the next error, which is known as OOMKilled. Okay, what exactly does it mean? So first of all, it's short for out of memory killed. Okay, now what exactly does it mean? What is out of memory killed? So basically, when you try to deploy an application, then a pod is getting created. Okay, so inside of the pod, we will be having a container. So let's say container has requirement of like 1 GB of RAM. Okay, it has a requirement of 1 GB of RAM, but in our YAML file, the two things we need to define in our YAML file. Okay, one is request, one is going to be limit. Okay, request is the amount of resource that is guaranteed available, that will be guaranteed available to our application. Okay, so let's say in request I have just defined 512 MB. Okay, limit also I have defined 512 MB, but in reality the application requires minimum 1 GB of RAM to work well. Okay, so what is going to happen here, that application in order to work well, it will start to request or start to utilize more memory than allocated. Okay, in that case, what happens, a condition gets triggered which is known as OOM condition. Okay, so when this OOM condition gets triggered, it's going to immediately kill this pod. Okay, pod will be killed and it will be like go down, pod will go down. Okay, so this going down of pod, it's known as OOMKilled error. Okay, now talking about how exactly we can fix it, right? So first of all, one more thing I'll tell you team, like how do we know that OOM condition is OOM error is coming? Okay, so when we run the command, we need to run this command kubectl describe pod, then pod name. Okay, so when you run this command, there will be a list of events coming. Based on that, you can understand what is happening. So in the event, when you run this command, when the event come, in that event, if you are seeing this condition, last state terminated, reason OOMKilled exit code 137. Okay, sorry about that. Yeah, so if you see the error, last state terminated, reason OOMKilled, and exit code 137. First of all, 137 code means the error is coming because of like less memory available. Okay, so if you see this error, you will understand that okay, this is because of memory issue. Okay, so what we have to do, let's say in our YAML file, we can define the resources in this format, request and limits, and here memory or CPU also you can define. Okay, now request is basically in request memory, what you need to define the amount of memory that should be guaranteed available to the application. Okay, limits should be the maximum amount of memory that application can request for. So these two values, we need to make sure that we are putting it like enough values that should be more than enough for the application to work well. Okay. So yeah, this is the OOMKilled error.